All right. Ever really stop to think about what happens in that split second when you power on your phone or your computer? Today, we're diving into the hidden instincts that bring all our tech to life. It's about a fundamental piece of the puzzle you use literally every single day, probably without even thinking about it.
So yeah, let's really dig into that question. You hit the power button on, well, anything. Your phone, your laptop, your gaming console. What actually happens right then? I mean, before you see any logos, before any loading screens. At that point, your device is just a collection of parts, right? It's just a chunk of metal and plastic until something tells it what to do. And that moment, that first spark, well, it's not magic. It's actually a really carefully engineered process. It all comes down to a set of instructions that have to be permanent, basically unchangeable, and just always there, ready to go, waiting to kick things off.
Okay, so the hero of this whole story is something called ROM, which stands for read-only memory. This is the component that holds those absolutely crucial first instructions. You can almost think of it as the spark of life for any electronic device.
So if we look at the textbook definition, there are two words that are just super important: non-volatile and permanent. Non-volatile is a fancy way of saying it doesn't get amnesia when you turn the power off. And permanent means exactly what it sounds like. These instructions are basically locked in. And here's the best analogy, the one that really makes it click. Think of ROM as the device's instincts. You know, like how a bird just knows how to build a nest without being taught? Well, your computer instinctively knows how to check its own hardware and get itself started. And that core instinct, it's all stored right there in the ROM. So what do these instincts really do, step by step? Okay, the second you hit that power button, the firmware on the ROM chip, and you've probably heard of this, it's called the BIOS or UEFI, it just jumps into action. First, it wakes up and initializes all the hardware. Then it does a quick health check, a little power-on self-test, just to make sure everything is plugged in and working right. And finally, its biggest job of all, it finds your operating system, Windows, macOS, and gets it started. But why ROM? What makes it so perfect for this incredibly important job? Well, it really boils down to four key characteristics. These are what make it the unchangeable, unforgettable, kind of like the brainstem of any device. First up, like we said, it's non-volatile. Super crucial. Second, it's the permanent home for all that essential firmware. Third, it's what we call read mostly. This is a big one. It means the system is almost always reading instructions from it, not writing new ones. This keeps those core instructions safe and sound. And last but not least, it has to be crazy reliable. I mean, if these instructions fail, your expensive device is basically just a paperweight.
And yeah, that non-volatile part really is the core concept here. Just imagine if your computer forgot how to start up every single time you unplugged it. It would be a useless brick, right? So this superpower of remembering without power is what makes everything else possible.
But here's a cool thing. ROM isn't just one static piece of tech. It's actually a whole family of memory that has evolved over the years. And with each generation, it's gotten a whole lot more flexible. So the story starts way back with something called PROM. You could only program it one time, at the factory, and that was it. Then, things got a little wild with EEPROM. You could actually erase it, but you needed to blast it with UV light. Yeah, not exactly convenient. The real game changer was EPROM, because you could erase it electronically. And that paved the way for what most of us use today, flash memory. It's just a faster, more modern version of EPROM, and it's the whole reason you can update the firmware on your phone, your smart TV, even your car. Okay, so we've talked a lot about the technical side of things, but where does this actually pop up in your daily life? Well, the simple answer is pretty much everywhere. You are interacting with ROM all the time.
And I'm not kidding. It's in almost everything that has a power button. Of course, it's in your computer's firmware, your game console startup sequence, your smartphone's core functions, but it goes way beyond that. Your printer, your Wi-Fi router, heck, even your microwave and your washing machine, they all have a little ROM chip inside with the basic instructions that tell them how to be a microwave or a washing machine. All right, now all this talk about memory brings us to one of the biggest points of confusion in all of tech, the showdown between ROM and its much more famous cousin, RAM. Let's clear this up once and for all.
Let's bring back our analogy because it works perfectly here. If ROM is the device's deep, unchanging instincts, then RAM is its short-term memory. You could say ROM is what the device is, and RAM is what the device is doing right this second. Let's just break it down point by point. First, purpose. ROM is for those permanent startup instructions. RAM is for temporary data while you're working.
Next, volatility. This is the big difference. ROM is non-volatile. It remembers. RAM is volatile. The second the power goes out, poof, everything in it is gone. That's why you lose that document you forgot to save when your computer suddenly shuts down. And finally, usage. ROM is for firmware, getting the system started. RAM is for actually running your apps and opening your files.
So here's the key takeaway. ROM gets the device started, and RAM runs it once it's on. They're not competitors, they're a team. You absolutely need both. ROM is the instinct that wakes the whole thing up, and RAM is the active workspace it uses to think and get things done.
And all this leaves us with a pretty fascinating question to think about, right? As our devices get smarter, more complex, and more connected to everything, how will these fundamental instincts stored in ROM need to change and evolve right along with them? Something to chew on. Thanks for joining me for this explainer.